Okay, improper integral. So far we've been doing this. Okay, we did two types of integrals. If it was, a numerical question, right? I asked you to integrate, right, like a to b, and that meant, right? That meant you're finding this area, right? That's what it meant. So these integrals look like this: integration from a to b, f at x, dx, right? Or the type of question we got was this: just integrate f at x, dx, and this is just asking you to find a formula which to find the area, right? We're not really saying which from where to where, but just find the formula. Okay. Now, improper integral, we're talking about this, except we're talking about infinite area. So let's say a. But I don't tell you to stop. I just tell you to go forever. Find this area here. Okay, find this area here. So, I mean, our first instinct should be, what? That should be infinity, right? Because we're constantly adding stuff. But it turns out that's not the case. It turns out some of them converges to a particular area. So how do we know if it converges? If it doesn't converge, so if it does converge, we say it converges to a particular value. If it doesn't converge, automatically we say it's diverging. Okay, converging, diverging. So that's summarized here. This statement, this little thing here. Definition of improper integrals type 1. Okay. So look, if you look here, it says we're integrating from a to t. Okay, a to t. But in this case, it's a, t is infinity. Okay, we're going forever to the right. So the way we determine whether it's going to converge or diverge is the following. We get an expression of this, pretending it's discrete, pretending it's a nice a to a particular value, right? And so this will turn into some kind of a function of, let's call it some kind of function with respect to t. Okay, that's what that will turn into. And we find the limit of that. So we turn into a infinite limit question, limit at infinity. Okay, so that's how we're going to do all of these. This one here, just instead of starting from a and going to infinity, it's minus infinity to b. Okay, so like I said, if it does equal to a numerical value, we say it's convergent. Otherwise, we call it divergent. Okay, in this part C, we're just integrating like this. So something like this. The example of something like this will be the following. Integrate the whole thing, the whole interval, from minus infinity to infinity. And the way we do that is we cut it up. Right, so we integrate from minus infinity to particular values a, and we go from a to infinity, and we apply part A and part B here. We turn into two limit question. Okay.